Here we go. We're on number 35. We've got Emma takes out a loan of $120,000, 17.2% per annum, PA, interest compounded monthly. That's normal. And we are taking a 20-year loan. Okay. So here's the deal. This $120,000 is going to be our present value of the loan. And the way I like to think of this is $120,000 in my pocket. It's not in the bank, it's in my pocket, which is why I'm going to make it positive. The interest rate for my loan is 7.2%. It's compounded monthly, so which makes this 12 and 12. Repaid over 20 years, so go up here and do 20 times 12. That's 12 compounds for 20 years. And I think we've got everything set up. Future value is 0. We want to go from this amount to amount of 0 that we owe. We currently owe this much. We want to owe this much in the future. So now we're going to go and find out our payment. Payment is $944. $944.82. So $944.82. Don't put a negative there. Our calculator, we need to be smarter than our calculators. Our calculators call that negative. But that's how much we're paying into the bank. That's why it's negative. 35B, calculate the amount of money still owing on the loan after 1 year. Okay. Here's how we're going to fix this. So what I want to know is the future value after a year. So how many compounds were there? This is the entire 20 years. How many compounds in 1 year? 12. So this is going to, if we make 12 payments of that much, how much is that going to go down? You might be surprised. Let's see. It went down, it went from 120 to 117. Interesting. 117 to 11.34. Well, that's interesting. C1. Calculate the amount paid in the first year of the loan. Now that's an easy calculation. We take the amount we paid per month and multiply it times 12, and you're going to end up with 11,337.84. And then for part 2, by how much has the principal been reduced? The principal is how much the loan is worth. Okay, so we started with a principal of 120. At the end of a year, we're down to a principal of 117. And so how much has the principal reduced by? It went from 120,000 to 117,000 and change. So that ends up being about $2,788.60. And at this point, you're like, hold on, something's not right here. Explain why the loan does not reduce by the full amount of your first year's repayment. So something's not right, because I paid that much, but my loan only reduced by that much. What is that? Why the discrepancy? That's a lot of difference. In that first year of you're paying your loan, you're paying a ton of interest, because what's happening is you're taking the 120 and then you're compounding that. So you're adding interest on top of that, and then you're paying off a little bit, and then you're adding interest, and then you're paying off a little bit. It's kind of like taking 2 steps forward and then 1 step backwards. Like you take a step forward by paying, but then you take a step backwards by getting interest. And so it's not reflected here. That's the answer to C. So write what you want for that. For D, suppose that after 1 year the interest rate falls to 6.95. Oh, nice. So this would be a variable loan, meaning the loan amount can vary. Typically, mortgages are fixed, meaning once you Once you get a rate, it's that for the remainder of the loan. So this is interesting because it varies. So here's how we're going to run these numbers. Here's what's happening. So we're going to change the interest rate to 6.95. The present value, so we've paid off for a year. So the present value needs to be this 117. Oops, 0.34. Alright, so after a year, it falls to that much and the interest rate changes. The present value, we're trying to pay it off. How many years now do we get to pay it off? We get to pay it off for 19 years now. Not 20. So 19 years. We're going to change that to 19 years because we've paid it off for a year. And now we're going to go and see how that affects our payment. So the payment was $944, and by dropping a couple tenths of a percent, that $944 turns into $927. So it's a little bit. 42. Where are we at? This was D. That was DI. Now here's DII. Last question. Emma is able to keep paying the original payment. So she's going to keep, instead of paying down, instead of changing her payments, she's going to keep the payments that she originally had, this $944.82. Okay, so now if she would pay the $927, she would pay it off in 228. That's 19 years. If she pays a little extra, this will change just a little bit. So let's go up here. So imagine that she's paying her loan off and she's paying extra now. How is that going to affect that number? So we're going to go and solve that one. 219.5. So 219.5 months is what that would be, which would be 219.5 divided by 12, which would be about 18, a little over 18 years. So 18.3 years, which would be 18 years, and 0.3 of a year is about 4 months. So 18 years, 4 months. So she, by paying just that little extra, by her interest rate going down and then her paying just a little extra a month, she turns her 19-year repayment into 18 years and 4 months. So she's saving quite a bit, actually, by doing that. She takes off 8 payments. Nice. 36. It's not a longer one. Oscar decides to start a new business venture which involves taking out a bank loan. The bank charges an interest rate of 6.55 compounded quarterly. That's not real. His quarterly repayments are $993. He must be repaid over 8 years. All right. Go to the finance app. Start a new business. The bank charges an interest rate of 6.55%. Compounded quarterly. So it's going to change those to 4s. The quarterly repayments are negative $933.62. That's how much we're paying into the bank, which is why I made it negative. Let's see here. And it is 8 years, so we need to change the number of compounds. And this is 8 times 4, because there's 4 compounds a year. 32 together for that. I think we're good. We're going to want to pay it off until it's 0 amount. And so now we're going to go to the present value. So we got everything set in here. Go to the present value and solve it. Looks like $23,110. So 36A is $23,110. B. How much interest will he pay over the 8-year period? Well, here's what's happening. This is what the loan started out as, and he is paying $933. He's paying 4 times a year, and he's paying for 8 years. So this is how much the loan was for, but how much is he actually paying? So do that calculation. $29,875. There you go. The question is, how much interest did he pay? So now subtract the amount for the loan, and you have the answer to the question. $6,765. That's how much he paid in interest. That's a lot. C. Calculate the outstanding balance at the end of the 6th year. So we're going to go back into our calculator, and here's what's happening. At the end of 6 years, I want to know what my future value is. How many compounds would that have been? That's 6 years times 4. So after 24 payments, or after 24 compounds, the $23,000 amount owed turns into, go to future value now, $6,947. So maybe at the end of 6 years, he gets his tax refund back and he's like, you know what, I just want to be done with this loan, and he just pays it all off. That could happen. C2. Oh, that was 1. Here's 2. At the end of the 6th year, Oscar pays a lump sum of $3,000 off the loan. Cool. So he brings his principal down. Assuming his repayments remain the same, how much sooner will Oscar repay the loan? So here's the deal. He takes this $6,947 and he takes off $3,000. So now the present value of the loan is now $3,947. So the question is, so he paid off a chunk, so now he only owes this much. He only owes this much. He's still paying that amount a month, and we want the value to go to 0. And I want to know, how long will it take him to now take this amount down to 0? So now we're going to go up to n, and we're going to solve. It will take him about 4.5 more months. So 4.42. For 4.42 payments. I didn't say months. 4.42 payments. And he's paying 4 times a year because he's paying quarterly. And if he's paying 4 times a year, so he's got about a year and a half, or not a year and a half, a little over a year. A little over a year to go. He's got 4 payments, that's about a little over a year. Assuming his repayments remain the same, how much sooner will Oscar repay the loan? Alright, so here's the deal. He paid for 6 years, and then he put a $3,000 towards the loan, and he's going to pay another 4 payments, and so that 6 years is going to turn into about 7 years. So the question is, assuming his repayments, how much sooner will he be able to pay? about a year earlier. By putting that $3,000 towards the payment there, he's gonna repay it about a year earlier. And that's all we're gonna go through on that one.